Hello, I'm Anna Mackay and today we're looking at polynomials. So a refresher on some facts about polynomials. They're of a form like this. Don't worry, you don't need to remember this. It's just the fancy definition. And some facts are that x is a variable. A0 is the constant term, so that's the term at the end here because it has no x attached to it, no variable. An is the leading coefficient, so that was here attached to the x with the highest power, so that's the leading coefficient. AR is the coefficient of the variable xr, where r depends on the power, and n is the degree of the polynomial, being the highest power. So if that n was a 4, it would be a polynomial of degree 4. Neatly written out here, the varying degrees. Now having a look at the first one here, it's not a quadratic. Why not? Because to be a quadratic we need power of 2, and so that's a linear. And notice that after each of them here, let's say looking at the quartic, it says a cannot equal 0. Have a think about why not. What if a was 0? What would happen? Well, that term there would be 0 multiplied by x to the power of 4. And what would happen to that? It would disappear. Essentially it's cancelled out. So therefore if that's cancelled out, the highest power you've got now is x to the power of 3. So it's no longer a quartic. So to be whatever power it needs to be, the leading coefficient needs to not be 0. Alright, some terminology here. If we're asked to state the degree of this function of p here, the degree is the highest power, and so it would be degree 4. The leading coefficient is the coefficient of the highest power of x, so our leading coefficient is 3. Always take note of the sign. The constant term, -5, not just 5. The coefficient of x, so you find your x term and it's +6. You don't have to write the positive sign if it's positive. The coefficient of x cubed, what would that be? -1, I hope you'd say. And the coefficient of x squared. Oh, there is no x squared. So if you can't see it, what must its coefficient be? It essentially is there. Essentially it's 0, lots of x squared, but we tend not to write that in, so the coefficient is just 0. Alright, 2 examples. Find the leading coefficient and constant term of this function of p. Well, to be able to find that leading coefficient and constant term, it has to be in expanded form. We have to be able to see each of the terms. So let's expand this. So we have p of x is equal to, now I'm just going to expand this in a slightly different way to start with, but feel free to do it in your method. Essentially what we're doing is the distributive law. So we are distributing out each term from one bracket with the terms in the other. So one way of thinking about that is you've got this -3 and you're distributing it to each of the terms in the other bracket. And when it gets multiple terms like this, it might get easier to expand it out if you do it like this. So there's our expanded form, and now we collect like terms. So we have one x cubed term, and just a point of interest, the only way we could get that x cubed term is from the 2 highest powers of x. Next we would look at the x squared term, and I've noticed that I've forgotten one. This 10 should be an x squared term. So we are left with 7x squared. Next we have x to the power of 1s. We've got -8, take 15, -23x, and our constant term of 12. So the question that we're asked to answer is, what is the leading coefficient? We have 2, and the constant term is 12. So that's that question. And one more. Find constants a, b, and c, given that this polynomial, what would it be called? A cubic, is equal to this. And again, a point of interest, how could we ever get that cubic term there? That would have to come from terms multiplied together to give a power of 3. And in this case, it would be a quadratic term multiplied by a linear term would give you x to the power of 3. Just out of interest, how could we get the constant term? We could only multiply constant terms together because any other terms would leave us with x in that term. Alright, so the way to do this is we're going to equate coefficients. So if we expand this out, we look at the coefficients of the x cubed, the x squared, etc., and we equate them to this here. So I'm going to expand out the bracket, and for space I'm just going to write it once what it's equal to, but I might not write it every time. And then we need to tidy this up. So collecting together terms with the same power. Now the next one would be x squared, and once again I've dropped off a square here, and this term. Now my advice is write that with x squared, and then essentially you're factorising out an x squared. So in this term you're left with 2b, and then the other term you're left with a. Then you're adding on the x terms, so that comes from 2cx and negative bx. Factorising out an x, you're left with 2c minus b, and your constant term is c. So we're equating coefficients. So the easiest ones to start with are the cubics. So having a look here, the coefficient of x cubed here is 2a, so therefore 2a must be equal to the coefficient of this x cubed, which is 6. So therefore a is equal to 3. Next easiest one is the constant term. So negative c is equal to positive 7. So negative c is equal to 7, therefore c must be equal to negative 7. And then we've got these two terms here. This is the coefficient of x squared. So 2b take 2a must be equal to the coefficient of this x squared, which is 7. We've got two variables here. However, we already know what one is. A is equal to 3, so we're subtracting off 3 and solving for b. So 2b is equal to 10, therefore b must be equal to 5. And it's probably worth checking that to just make sure you haven't made a mistake. So this is the coefficient of x, which must be equivalent to negative 19. And we already know c, which is 2 multiplied by negative 7. And solving. So then we have negative 19 plus 14, where negative b is equal to negative 5, therefore b must be 5, and that's what we're expecting. But go back and read the question. It asks us to find the constants a, b and c. Therefore a is equal to 3, b is equal to 5, and c is equal to negative 7. Okay, so the next video in this series will be 4b, zeros, roots and factors. Thank you.